When you're watching these videos, try to do all of the warm-up problems by yourself and then check your answers. You might have to pause the video first. Here are the solutions. For the distance formula, your best bet, which is the easier method than how a lot of you did it on the quiz, is to ask yourself how far apart are the x's? They're 7. How far apart are the y's? They're 7. And use Pythagorean's theorem, 7 squared plus 7 squared equals the distance squared. That's 98 equals the distance squared. The square root of 98 is 7 square root 2. For absolute value problems, because absolute values are asking you about the distance from 0, what you need to think about is the distance from the center. And you can't tell the distance from the center without making a graph. So for this problem, I had minus 3 from all three sides. Get negative 5 is between x and 3. Then I would draw a number line and establish the center. Now some of you already know the center, but some of you need to visualize it. So if you're visualizing this, they're 8 apart. And if they're 8 apart, that puts the center right here at negative 1. So because this is centered at negative 1, I'm going to write the absolute value of x plus 1. It's kind of like the circle equation where you always do the opposite to get the center. And then since you have to go 4 to the right and 4 to the left from the center to get the absolute value, it's all points centered at negative 1 that are within 4 of negative 1. That's the absolute value equation. It requires visualization and knowing about centering, so it's a little bit trickier than some of the other things we've done. For the last problem, it's just a matter of order of operations. You should have negative 2 minus 3 parentheses negative 2 minus 3 squared. For your first step, you're going to do inside the parentheses, so negative 2 minus 3 times negative 5 squared. Keep in mind when you square a negative it becomes positive. Negative 2 minus 3 times 25. You simplify that, the answer is negative 77. These are the different forms for equations of lines. Equations of lines are actually really easy. The students usually have a hard time with the instructions. So you have to make sure that you know when it says general form what general form looks like. You know when it says point slope form what point slope form looks like. When it says slope intercept, you know what slope intercept forms looks like. You have to know also that if it's a horizontal or vertical line, you're just going to memorize it. You don't have to work it out, you just have to write the answer. So we're going to go through some examples of each of these problems. Let's take a look at a graph first. The graph in this example is easiest to graph if you find the x and y intercepts. To find the x-intercept, you're going to make y equals 0. Just imagine that you actually make the y value 0. So in the equation that's listed as 2x plus 6y equals 12, get rid of the y. It's 0. So you end up with y value being 0 and x value being 6 because 2 times 6 is 12. Next, you write the same equation, 2x plus 6y equals 12, but in this instance, you're going to make the x value 0. So x is 0. Imagine I get rid of it. 6 times 2 is 12. So the y value is 2. With a y value of 2 and an x value of 6, it's pretty straightforward to make the graph. For the next problem, if it just says find the equation, then you're pretty much set with y minus y1 equals slope times x minus x1. before you get to that, you need to work out the slope. If you're good with slope, you can use the equation and do y2 minus y1 over x2 minus x1 and get negative 2 over 6, or negative 1/3. If you tend to have a problem with working out fractions and working out negative and positive signs, it might be easier for you to just think about the slope as the change in y over the change in x. If you go back to the original question, y changes from 4 to 2, and it goes from 4 to 2, so it's going down 2. X changes from negative 2 to 4, so it's going to the right 6, and so the slope is negative 1/3, and it's all in your head instead of working it out with a formula. Then on the next step, if it just says write the equation, you'd be done by writing y minus 2 equals negative 1/3 times x minus 4. But if the problem says to write the equation in general form, then this is really just the first step. And to continue to general form, you need to distribute the 1/3, then multiply by the common denominator to get rid of the fraction, like you did on the last quiz. Then move the x and the 4 over to the right. This is the general form of the equation, and you're not going to be able to get the general form unless you first do some work, and that work is going to include finding the point-slope form first. For the last problem, find the equation with a slope of 0. That's the one you have to memorize. As soon as you realize that it says slope is 0, you need to think to yourself, that's a horizontal line. If the line is horizontal, its equation is y equals 5. No work necessary. The next lesson is on complex numbers. Complex numbers have a real part and an imaginary part, and you need to take a look at the definitions, the most important one being I squared is equal to negative 1. So whenever you see I squared, I always think to myself, or remind students to, think poof, like you're waving a magic wand. Because it's imaginary, it changes to negative 1. When you were in your Algebra 1 class, you would do an algebra problem that was set up like this. You always write it out twice if it's squared. You can't just square them both. It doesn't work out to be the same thing. And you end up with x squared plus 3x plus 3x plus 9. You combine like terms, x squared plus 6x plus 9. That's FOIL. If you were to do a similar problem in pre-calculus, you'd actually have a lot more work to do. Notice I have it cubed instead of squared. This is going to be 4 minus I times 4 minus I times 4 minus I. In the first step, we're going to FOIL. 4 times 4 is 16, negative 4i, negative 4i again for the outside, and negative I squared for the last, and then you need to take out the magic wand, poof, that becomes negative 1, minus a negative 1 becomes positive 1, so you end up with 17 minus 8i. But you have to keep going and FOIL again, 17 minus 8i times 4 minus I. You then continue to FOIL. 17 times 4 is 58, 68 actually. So it's 68 minus 32i minus 17i plus 8i squared. As soon as you see the I squared, poof, it becomes negative 1. So you end up with 68 minus 49i minus 8, which is 60 minus 49i. So you're treating i's exactly as you're treating x's. It's just whenever you see an I squared, poof, you change it to negative 1. If you're simplifying an imaginary number that has a fraction, you have to deal with what's called the complex conjugates. And an example of that is asking you to simplify a problem like 2 minus 4i over 1 plus 3i. The conjugate of 1 plus 3i is 1 minus 3i, and you have to know to write that in on both the top and bottom, and then FOIL them both. So if you're going to FOIL the bottom, the nice thing about complex conjugates, as you can see over here from the example, is the i's are always going to cancel out. So the bottom, if you're using FOIL, is going to be 1 minus 3i plus 3i minus 9i squared. As soon as you see the I squared, poof, it becomes negative 1. That's 1 plus 9, so the bottom of this complex number is 10, 1 plus 9. To work out the top of the complex number, you go first is 2 times 1, outside is negative 6i, inside is negative 4i, and last is 12i squared. And as soon as you see that I squared, same thing happens. Poof, it becomes negative 1, resulting in 2 minus 12, which is negative 10 minus 10i, over positive 10. All of these are divisible, so this final answer is negative 1 minus I. This last slide is just good practice for the ACT and the SAT test. A really common problem on both of these tests is just asking students if they know how to look for patterns in imaginary numbers. And so if you follow along with this, right here we have I, and then right here we multiply it by another I times I becomes I squared, which is negative 1. So I squared is negative 1. If I want to figure out I cubed, I take I squared times another I. Since I squared was negative 1, negative 1 times I becomes negative I. So I cubed is negative I. If I want to figure out I to the fourth, that's I squared times I squared. Remember, I squared was negative 1, so negative 1 times negative 1 is positive 1. And if you look for the pattern, and I've got the pattern set up down here, it just repeats. And what you really should key in on is anything to the fourth power is always equal to 1. That's what you have to remember. Any power of I to the fourth is always equal to 1. So if you were to be asked a question on your SAT test, what's I to the 102nd power, you can think to yourself, well, that's going to be equal to I to the 100th times I to the second. I to the 100th is the power of 4, so it's 1. And I squared is negative 1, so I to the 102nd power is negative 2. This is actually not something that's going to be on your homework assignment, but it's a good practice for the SAT test.